Hello, everyone. Hey, Hanan. How's it going?
Hey there. Good, good. How are you doing?
Doing great. We're live. This is Dev Office Hours. Thanks, everyone, for joining. Um, Today's Dev Office Hours is going to be slightly different. Last time, I kind of try to present the things that we have um, already available, working and polished, so to speak. Today, I'm just going to be showing everything we have, work in progress, everything. So let's see how that goes. Hopefully, it's going to be useful and interesting. So, uh, yeah, feel free to ask questions, of course, on Discord. We have Dev General channel as well as on X. If you go to Zeta Blockchain X profile, there is a live stream. You can ask questions there. Uh, I'm going to be sharing my screen, so Hernan, if you see any good questions, just stop me and let me know, and uh,
Will do.
we'll try our best to answer all of them. Okay, so let's begin. Let me just share my screen and let's see. Okay, so you should be able to see my screen, and um, let's take a look first at the toolkit. So we've just released a new version of Toolkit, which is V13. It took us a long time to release a stable version. We've been shipping release candidates, which is less than ideal, but now we have a brand new stable version, a bunch of changes. We've upgraded the toolkit to Ethers V6, which is awesome because it's the latest version and we want to keep everything up to date, and it's going to make it easier for us to actually integrate it with the rest of the tools. For example, LocalNet has been V6 for a while now, so now everything's V6, and that's awesome. We've added some Solana functionality, a bunch of fixes, refactors, and so on. But one of the cool initiatives that we started in V13 is migration to ZetaChain CLI. So ZetaChain CLI is something we have not publicly announced yet, but we're and I'm gonna briefly introduce this upcoming project. So basically, ZetaChain CLI is a dev tool that is published on npm and accessible on the terminal, right? So it's a CLI tool for ZetaChain developers building universal apps. And the reason why we need a CLI, which is actually separate from the Node CLI that you already know if you're a validator, probably not if you're just kind of building or using the blockchain. So ZetaChain CLI for developers is going to be your kind of go-to tool for building universal apps, and it's going to tie every tool we have, um, every tool example, everything into one, hopefully very pleasant to use CLI. And the reason why we need a tool like this is because up until uh, this point, we've been using hard hat tasks, which is fine, but hard hat is an EVM tool, and ZetaChain, of course, is EVM compatible. We have so many other blockchains now connected to ZetaChain, so it doesn't really make sense to use hard hat for um, for ZetaChain anymore. We're still going to be using it for development purposes when building on ZetaChain EVM, but we don't want to use hard hat tasks for broadcasting Solana transactions or Bitcoin transactions. So in the past, I mean currently, but kind of hopefully in the past, we had like NPX, hard hat, Bitcoin deposit and call, which worked, but this is a Bitcoin transaction, has nothing to do with EVM, and we just used hard hat as a task runner, which it is not. So what we're going to be doing is transitioning to a separate CLI, and it's going to be accessible. Just increase the font size a bit. Okay, so npx ZetaChain, right now it's released, so next. So this command will just open the CLI. If it's not installed yet, it's going to pull it from npm and make it available. So right now we only have essentially two commands. One is new. So if you run new, it will show all the examples we have, and you can, for example, create a NFT project. So it just kind of clones the universal NFT example, and you can start building. It's pretty convenient. You don't have to use Git manually, and it has some nice descriptions and all. So it's going to be like the go-to way of getting started and cloning examples and so forth. And we also have localnet. This is actually previous version of localnet, but it still should work. So start, stop, check all the localnet commands. So if you run localnet start, hopefully it should start localnet. And again, this is not running an example project. It's just running anywhere, your home folder, where, right? So it just starts localnet. Pretty cool. And we're going to have a bunch of these commands. So in this CLI, we're going to have EVM, Solana, Bitcoin, namespaces with all the commands related to these blockchains. So it's going to be pretty cool. So this is upcoming, and we're transitioning the toolkit to the CLI. So essentially converting all the hard hat tasks we have right now into commands. And we already have a few of them. One thing that we kind of have to do is transition to our own key management system, so to speak. It's nothing fancy, definitely not production ready. You're not going to be using this for production, but essentially for development purposes, when you're building universal apps and you're interacting with different blockchains, non-EVM blockchains, you need to make sense of all of this and have keys somewhere that you can access that are basically for every chain that is connected to ZetaChain. So when you're developing, you want to send a transaction from Solana, from Sui, from Arbitrum, from Bitcoin. And for the CLI to be able to access all of these commands, all of these keys, we need a system, and it's still a work in progress. So I'm going to switch to the toolkit repo, switch to main, make sure that, okay. So yeah, this is just me in the toolkit repo, which already has some of this functionality. So if you type in ZetaChain, it's kind of like a preview of the functionality that we're going to have in the CLI, except it's running on the toolkit. So we already have this accounts namespace. Yes, I meant accounts. So we have, let me just help so it doesn't show as red. Okay, so we have a basic CRUD for accounts, create, account, show, list, delete, that sort of thing. So what you would be doing is essentially accounts create, name, Bob, type, EVM, and it's just going to create a new key, store it here, and now the CLI knows that you have this Bob key, which it can use to send transactions from EVM. So everything's going to be stored in this .zetachain directory under keys, all very organized and structured. So you'll be able to create Solana keys and so on. So this is kind of relaying groundwork for all the future functionality features that we're going to have. Very important to have key management. Again, not something you're going to be using in production, but definitely very useful when building universal apps. And we have a bunch of functionality in OpenPRs. Actually, some of it I might even demo right now. So let's see what we have. In account improvements, we actually added SUI support. So we need to still add ton, but yeah, we're getting there. And yeah, let's take a look at Bitcoin. So we now have this functionality. We have had this for a while, which is inscription support, right? So as you may know, you can call universal apps from Bitcoin, and you can use memo inside OP return, which is limited to 80 bytes. It's been working fine, but it's kind of limited. If you want to send more data, then you would be using inscriptions, and we've added a command to encode data specifically for that, so you can put it in a Bitcoin transaction and witness data and broadcast it. So let me just switch to so now we're in the Bitcoin inscriptions PR, and let me just so yeah, now we have this Bitcoin namespace. It only has encode command right now, but we're gonna have deposit and call and some other commands here as well. But the encode command just takes parameters such as types, values. By default, it encodes using a ABI, and it supports different type of calls. By default, it's a positive call, but you can also just do a deposit. For example, we just want to send BTC as ERC20 BTC on ZetaChain, but what this does is it basically takes data and encodes it in a way that is compatible with how ZetaChain expects data to be bundled inside the inscription on Bitcoin. So this is the data, and we need to add functionality to actually broadcast this data as part of a deposit and call command. Work in progress. And what else? I mean, we can circle back to all of these commands, but I just wanted to highlight what changed in V13, and this is what we're working on, converting tasks into commands and making sure that we have all the commands we need for all the chains we support, which is BVMs, Solana, Sui, Bitcoin, and Ton. Now let's move on to LocalNet. So LocalNet is a very useful tool for developers to have essentially ZetaChain environment with all of the connected chains running locally without you having to interact with testnets or mainnets very quickly. A very short feedback loop. Just start LocalNet and deploy a contract, and you can interact with it instantly. Very convenient. So we've just recently, so we last week shipped a new version of LocalNet, which adds Ton support and Uniswap v3 pools. So let's use this version and actually check out the new features that we've added in V9 and V8. Just a recap of V8, we added smooth run call. So I think that would be kind of interesting to take a look at, because we still haven't published a tutorial for this, but it's already available. So just let's dive in and see how that works. Okay, so what I'm going to need is a LocalNet repo. You can follow along if you want. Just clone LocalNet, check out the main branch, make sure it's synced. And we're going to need a toolkit. We're going to need example contracts instead. So that since this is not yet merged, it's in a branch suited run call, so you can check it out. And let's open a let's open the tutorial. So for the tutorial, you can go to withdrawn call example and click view deployment. So this is the link, and it's going to be merged probably pretty soon. But for now, it's in a preview. So what we're going to do in this example is deploy a SUI contract that simulates essentially a DEX, and we'll make a call from ZetaChain to this contract. So we'll withdraw SUI tokens and call this DEX contract. Going to be a lot of copy pasting, but hopefully it's still going to be useful. So first of all, let's start localnet. So we are in localnet. Let's type start. By default, localnet will start all the chains that you can, essentially. So if we don't want to start some of them, we can just skip them. So that's what I'm going to do. I don't need Solana for now, and I don't need Tom, just so that it launches faster. Okay, so this should hopefully launch localnet with SUI. So many things going on under the hood. Okay, so we now have both ZetaChain and SUI running. Let's go into example contracts. Again, I'm in this SUI withdrawn call branch. The SUI example is inside examples call SUI. So examples call SUI. And let's just follow along the tutorial. Okay, so first of all, we need to deploy, build the contract, get some SUI tokens for the account. So localnet should give you tokens, but just in case, run a faucet. And now we're going to be publishing the contract. So all these commands, just run a command and save the output in a variable, which is then used by other commands. So we've published the SUI contract, saved it into the published variable, and now we need to get the package ID from the published package. So this is package ID saved under the package. Next, this is going to be specifically about the pools. So we've published the contract, which is super simple actually. It implements on call, and don't worry about these commands. I mean, these functions, they're for example for call examples. But what we're interested in, this on call function, which basically uses Cetus, which is SUI DEX. It swaps some tokens, and that's it. But of course, when we deploy a contract, we deploy this contract as well as other contracts in the same module, which is a mock contract for the DEX as well as a token. Because for a DEX, you need at least 2 tokens. You need to swap between them, right? So we've deployed the mock DEX contract. So now we just need to extract all the ID of objects. So treasury, pool ID. Recipient is going to be our currently active address. And now we need to mint some of these tokens. So this is the token contract. We're going to just mint some of them to ourselves, so we can later on deposit them into the pool. So let's get token ID and deposit tokens into a pool. So we've deployed the DEX, deployed the token contract, and now we've deposited some of these tokens into the DEX on Sui. I'm not a Sui expert, but kind of high-level overview, pretty clear what's going on. I think what we're most interested in is how you actually call this contract from ZetaChain. We're going to get to it pretty soon. So let's get all the coins. If you just run client gas, you're going to get all the coins. Sui is different from EVM in that essentially it's kind of similar to Bitcoin in a way where you have the same token, but it's like different outputs, but here it's like different objects. So we just take the first one and use it to deposit. So this is just like the first coin that we have. Now let's set ETH address, which is the recipient on ZetaChain. Let's go back to our local net and just copy the default address. Next, gateway package. So gateway package you can get from this nice table. It's called module ID. So gateway package. We should actually rename this from module ID to package ID, I think. But yeah, gateway object. So this is going to be automated because in next version of LocalNet, we're going to store all of this data, all these contract addresses in the home directory. So it will be easy for contract scripts, not for contracts, but for scripts to actually just programmatically read all of these values. So you wouldn't need to copy and paste, but for now, this will have to do. So here we're going to be depositing Sui into the gateway address so that it shows up as 0c20 on ZetaChain, so we can then send it back. So Sui client call, we're calling the gateway package and just sending some coins to the ETH address, which is our default address on ZetaChain. So let's see if that works. And we see now on LocalNet that the gateway received the deposit event, and on ZetaChain, some Sui tokens were deposited to our address. Cool. So that's how you deposit tokens from Sui to ZetaChain on LocalNet. Pretty straightforward. And now let's actually do withdraw and call. So these are just parameters from same published output that describe the objects related to the DEX, and we need to get them first from the published output and put it in so that we can use it then in the payload. So let's get config, make sure that you see the address. If you don't see the address, it means it's not in the published data, which is a problem, but here we see all the addresses are here. Now the message that we're going to be decoding on Sui side, so this data here is going to be just a recipient. So here, decode receiver from data, and we're passing recipient address in the message. Now let's get token type. So this is the token that we deployed on Sui, which will be used to swap. And now the payload. So right now we're just using the script in the setup directory, but this is already available in the toolkit and it's going to be exposed in the CLI. So this nice blob of data is the payload that we're going to be sending as our instruction to withdraw and call. And now let's actually approve ZRC20 token so that the gateway can use it. Okay, this is just a pound request command to approve ZRC20 Sui, so that gateway can so use it. And now we're performing withdrawn call. And you can see, awesome. So we see an event, a transaction on ZetaChain, and on withdrawn call has been called, and we're withdrawing 0.001 SUI tokens and calling contract from the gateway. So we're calling this contract. We don't see any output here, but there was no errors, so we kind of just assumed that it succeeded. But of course, we would benefit from like more logging, I guess. We have set up logging for like universal apps because it's easier, but we probably need to add some logging to SUI as well. But you can use SUI CLI to actually query the balance of the token and see that it has changed. But yeah, basically that's how it's gonna work on testnets and then mainnet, but you can already kind of play with it on localnet. So all of this was to just see this line, honestly. So hopefully that was exciting. If not, let's move on to something else. Ton can be exciting. Let's run Ton. Why not? So let's kill the localnet instance. We no longer need it, and let's play with Ton. So we don't have withdrawn call on Ton yet, but we do have deposit. So let's just try running that. So for Ton is actually running on Docker. It's not ideal. I prefer not to run stuff in Docker if I can help it, but here we cannot help it. There's just no sane way of running Ton outside of Docker, so that's what we're doing. Docker desktop does not work on my machine at all, so I'm using Colima. I don't know what the name is, but it's just basically a program that runs Docker containers without you having to run Docker desktop. So let's wait for it to start. And now let's try running localnet again, and we're going to skip Solana. Don't need it. I'm going to skip SUI. This might take a few minutes to start, simply because it's deploying protocol contracts, trying to connect to the container where Ton is running. So you'll just have to wait for all these attempts to go through. In the meantime, since Ton is not yet available on testnet, okay, sorry about that. Since Ton is not available on testnet, we have all the commands here in localnet. So if you run your localnet, you have a Ton namespace for Ton commands. And I think that's how it's gonna work in the future, where we add new features to localnet first. And since these commands are only relevant for localnet users, we're just going to keep these commands in localnet, and then they'll kind of graduate into toolkit commands once this functionality reaches testnet. Okay, Tom is not ready. Keep waiting. It is ready now. So yeah, it takes a minute. But yeah, inside localnet, we have this Ton namespace, and now it has a few commands to check balances, to access faucet, wallet commands, and withdraw command. So Ton gateway deployed, awesome. Now we can continue with everything else. Everything else seems so fast in comparison, but yeah, and it's working. Awesome. We have Ton running in Docker in localnet, and let's try it out. So we have some examples here. I'm going to convert into tutorial, but for now, we're going to need protocol contracts ton to actually send a deposit. I mean, we can use it. We can probably do it in social different ways, but it's kind of convenient to do it from the protocol contracts.
Hey, Dennis. Sorry,
Yeah.
we have a question here from the audience. They are asking if you can stream at 1080 or above. I don't know if that's something you can configure.
1080p. Okay, let me.
Or in any case, at least, yeah, make the font
Yeah,
bigger.
I'm just
That's a
gonna
help already.
increase. Okay, cool. Yeah, and actually, like this call is recorded in high def, but when streamed on X, I guess it kind of compresses. So hopefully, this is more visible. But yeah, let's see if I can make it bigger. Okay. Protocol contracts ton. I need it. Where is it? So let's see if I have it. ZetaChain protocol contracts on. Okay, so hopefully this is more visible. And let's install our dependencies. Run a command. So this is just gonna send the command. Okay, so I'm gonna do it. Mnemonic deployer was chosen, but n variables were not set. So we need to set. Okay, let's create a wallet first. Kind of missed the step. So inside localnet, creating a wallet. Hopefully it's going to print a mnemonic that I can use. Awesome. It's going to have a mnemonic. Go back. We need to get some tokens. You can actually do it automatically in the future for default address. I don't think we have a default address on localnet right now. Getting some tokens. It's supposed to be a diamond, I think. Okay. Let's check the balance. Okay. Working. And now I guess what we need is go back to protocol contracts. So wallet mnemonic needs to be set. And mnemonic. What version? It's default to v5r1. Okay, let's set v5r1. Try again. Guess it's not reading the thing. Let me. What version? Okay, nice. So yeah, you have to pass it here. I guess it's my shells thing, but yeah. Enter gateway address. And we no longer need examples. So let's go back to localnet output and get gateway address. Select command. I'm gonna deposit. Enter recipient address. Just gonna take the default. Okay. Oh, nice. It works. So the gateway deposit was registered and some tokens were minted and transferred to this recipient, and this should be the TON token. So just check that it is. Yeah, it's ERC20 TON. Cool. Now we have TON tokens. Let me actually just send more, just in case. And gateway address, deposit, send 5. Okay. Cool. Let's check out withdraw. So we're using localnet on withdraw command, gateway. Let's check that the gateway address. This is ZetaChain's gateway. It should be the same always, but after we add more functionality, like the address may change, and that's what actually happened. So now the gateway ZVM, after adding TON, it changed. So it's always nice to check. So token, check that. Yeah, oh, it's different. Yeah, it's the same 891. So we're withdrawing ERC20 TON private key. Get private key of this address, which is Anvil's default private key, amount 1. And address is, I'm assuming, is the receiver, which is this value. So to out quotes, because there's a colon, you never know how the cell is going to interpret it. Cool. So we are not a deposit skipping. Interesting. I actually don't know what it is. So not a deposit skipping. Interesting. Let's try to debug it. Maybe it's not a bug, but not a deposit. Okay, yeah, that's definitely. Yeah, we're gonna have to debug it. Not now, but in any case, deposit works, withdraw throws an error. Gonna create an issue for this. So yeah, this is work in progress. But okay. Well, we found a bug. Always great to find bugs earlier, sooner than later. Okay, let's move on to something else. We have, what else do we have? So TON is almost working. Let's debug it later, but we've also added Uniswap v3, which is actually, okay, let's start localnet again. Turn localnet start. Skip Solana. Sui TON. So in this new version, we actually have both Uniswap v2, which is we don't have v2 actually, but it's just Uniswap factory and router, and we also have v3. The reason for this change is that in production on testnet and mainnet, Uniswap v2 is going to be used primarily for gas swaps, so it's going to have less liquidity. It's still going to be there because the protocol needs kind of a reliable, low maintenance pools for swapping tokens when the protocol handles withdrawals, reverse. But for all applications that actually need deeper liquidity and more modern DEX, we're going to be recommending use one of the DEXs, but some of the DEXs actually use Uniswap v3. So this is what we're going with on local nets and testnet. And we now have this functionality, so you can already kind of simulate behavior of Uniswap v3 on local net. And we're updating example contracts to match this. So we have Uniswap v3 pools. So it's not going to be very different from the current implementation, but yeah, essentially we're going to have a separate swap library that implements v3, and it's going to be the same swap tokens for exact tokens like you had in v2, except it's going to be using v3. And we'll be adding, well, I mean, we're already adding functionality to actually interact with these pools. So in the toolkit PR, we have Uniswap v3 deployment and liquidity commands, which I'm actually using to add liquidity to these v3 pools. On testnet, on local, you don't need to use these commands because v3 pools are set up by default. But on testnet, this is going to be useful because when new tokens are added, we can just run these commands and add some liquidity. So yeah, this is one of the upcoming features, but it's available already on localnet. One thing I also wanted to mention is, oh yeah, basically, let's talk about protocol contracts. So as you know, when you build universal apps, let's open this. Let's take a look at the most simple example. We have hello. So when building universal apps, you implement this on-call function, right? And it has variable called context of type message context. Let's open protocol contracts and take a look at what is actually inside the context phase. So yeah, inside message context, we have information about the sender, which corresponds to an EOA or a contract on a connected chain that actually triggered universal app. And we have a chain ID. Soon we're not soon, but like in the next version of the protocol, we're going to change some of the behavior here. So let's take a look at how it works right now. Let's E12. So right now, message context has bytes origin, address, sender, and chain ID. Ignore chain ID, it's the same, but the change that we're going to introduce is instead of having origin and sender, so origin is used right now for non-EVM chains. So when you're making a transaction from Bitcoin to ZetaChain, your batch32 address is stored as bytes inside this origin property because it doesn't fit in the address. Obviously, it's not a hex EVM hex address. So we put it here. For Solana, same thing. For Sui, even though it's hexed, it doesn't fit in the address type of Solidity. And we have this kind of dual system of origin and sender, and you have to use the appropriate one depending on where the call is being made from, which works, but we decided that we're gonna kind of streamline this and essentially put everything in just bytes sender variable. So it doesn't matter which chain you're making a call from, be it Bitcoin, Solana, Sui, Ton, EVM, it's all going to be in the sender. So you just use this and you're going to get the sender address. It's always non-empty and it's always bytes. This is also convenient because when you're making a withdrawal, for example, withdraw and call, it actually expects to see bytes. So before you would have to possibly use API and code packed to convert whatever you have into bytes. Now you wouldn't need to because you would just take the sender and use it in withdraw if that's what you want. And for convenience, we're also going to have sender EVM, which is only going to be not null if the call is made from EVM. This is made for convenience, but also for backwards compatibility. So I really like this system because it means that you just have to worry about one variable, which is sender, and you just decode it depending on the length of the variable. So text address is going to be 20 bytes, and there's I don't remember how many, but I think it's just going to be much easier to use the protocol. And of course, we're going to update examples and everything, but yeah, just kind of a heads up that this change is going to happen in the next, 4 to 6 weeks. Okay, what else? Okay, I don't think I have any other updates. We kind of covered a lot. Hernan, do you have any questions? Check Discord.
No, we don't have any unanswered questions.
Okay. One actually thing that I can also mention is we're updating the swap example. So for a while now, the swap example wasn't really compatible for swaps coming from Bitcoin and going to non-EVM chains like Solana and Sui because it expected a text address as the recipient. We're changing this in this PR. So still open, but what it's going to do is just decode whatever address you throw at it and use it to withdraw to the destination chain. It doesn't work with Solana right now. I mean, it does. It's just the way Solana address is encoded is so when you're making a call from Solana to ZetaChain, the sender address is actually Solana address as a string converted into bytes. So it's a pretty long string. So we're not decoding base 58 into bytes and then kind of sending that. But instead, right now, we're just taking string as is and converting into bytes. So it's a pretty long string. It doesn't fit in default OP return. So I don't know if we're going to change it or keep it this way, but if we're going to keep it this way, you're just going to have to use inscriptions. Not a big deal because for most purposes, you're going to want to use inscriptions anyway. But yeah, just something to keep in mind. But other than that, tested with Sui, it works. So yeah, hopefully the swap example is going to become much more useful with this. But yeah, I think that's pretty much all I wanted to cover, really. Anything I'm missing?
I don't think there is. I think that was a really complete walkthrough.
Yeah, it was kind of rough around the edges, but I think it's fine. Like we're building all of this as we go, testing in production. Well, not the protocol team. The protocol team is actually testing before releasing to production. But when it comes to tools, I think we have some space to actually kind of experiment and skip some commands that are like super new. and then use the latest features. So if something breaks untested, nobody gets hurt. Don't use these commands on mainnet. If you do, it's on you, honestly. We should have like a big disclaimer saying don't use it on mainnet.
You probably should, yeah.
But yeah. Well, this was definitely a different format. I don't know, Hernan, do you have any questions, any thoughts on all of this?
I mean, nothing really comes to mind at the minute. I think it was, really well presented, and I think it was overall a really good representation of where we are currently sitting on the DevX space. So yeah, really good to see.
Awesome. Well, thanks everyone who tuned in. Hope you enjoyed it. We're gonna host these calls, of course, every month, and we'll be sharing more awesome stuff that the ZetaChain is building. And yeah, thanks so much for tuning in, and see you in the next one. Have
All
a great
right,
day.
see you next time.
Goodbye,
Bye bye,
guys.
guys.